Yeah. Well, hello, everyone. I think there'll be a few folks joining us. There were 25 that registered for this webinar. Certainly appreciate that. I see about 11 or 12, 10 that have joined. So I think there'll be some stragglers here, which is absolutely fine. But for the sake of everyone's schedule, I'd like to just begin. My name is Jeff Floyd. I looked at the registration list and recognized a number of names and companies. Got folks from California, Midwest, and about half the list from the great state of Florida. And I've a brief history myself. I've been with NAMA, a member of NAMA since the early 2000s, and ran an HHW facility in Western Wisconsin. For a number of careers since then, but have remained active in the group. And it's sat on board for 10, 12, 14 years, something like that. This is only my second webinar. I'm excited to present some new information on AI and machine learning and how that can impact our industries, which are our waste and recycling industries. I know this isn't a back and forth. There'll be time for questions afterwards, but to get started, not really a show of hands, but let me just ask some questions anyway. How many of us on this call are directly responsible for running facilities or warehouses? And we guess that if people could raise their hand, that would be a significant number of the folks on this call from running public works operations that include food landfill and HHW facilities, might be related to water treatment, stormwater, might be related to MRFs and transfer stations, might be related to electronics recycling or medical waste processing across the board. We folks in this call and folks in this industry touch a lot of what we do in this country for collecting and processing and reusing our waste. If I ask for the same group, when you're looking at warehouse management, what the key number one priorities are, I would assume that many of us would raise our hand and say safety. That's number one. Would say compliance and reporting are our top priorities at all of our facilities, regardless of what we're doing at the individual facilities. And I would agree with that in my time running operations as well. I think the next question specifically related to the topics we'll be discussing today. How many of us have heard of AI? You can't go 30 minutes in social media or on the news without hearing something about how AI is taking over the world, maybe ending the world, and the power that it's providing to many segments across the world, the benefits that it can have, and maybe some challenges. What's interesting is, to me, is that AI generally has skipped waste and recycling. And I want to discuss the fact that I see that changing. I see that changing rapidly. But if you think about how AI and machine learning has impacted our industry to date across waste and recycling segments, it's pretty limited. There's plenty of AI chatbots and trivia and you can write term papers apparently, which they can do that when I was in college with AI, and even drive cars autonomously with AI. But in our industry, outside of a camera at times identifying a PET water bottle and having a suction cup on a robot arm remove that from a sort line, there's been little advancements in automating our processes and systems within our waste recycling and hazardous waste systems. So I'm presenting to you from a company called Visia by Bennett. It's an AI software automation company that pairs cameras and X-rays in waste and recycling operations to do just what I said is missing, which is giving true visibility to material composition, identifying hazards, and also providing actionable data so that staff and or robots can make decisions to improve efficiencies, reduce hazards, and improve productivity and ultimately value. It's the biggest challenge when it comes to understanding and managing our operations. I think the answer could be summed up as visibility. You don't oftentimes know what exactly is coming in. I believe Richard Vinsky's on this call, an expert in identifying unknowns, as many of you are. When a liquid comes in some kind of a container and you don't know what it is, expand that to a MRF setting or to a landfill and to an e-waste facility where it's important from a customer standpoint, it's important from a billing standpoint, but it's ultimately important from a process standpoint to understand if there's hazards, if there's non-conforming waste, or if the material that is said to be delivered is actually what is supposed to be delivered. And this, ultimately is the largest challenge that I see and have seen in the industry. And up until maybe recently, it had little impact in using manual processes to identify hazards or to guesstimate a contamination level to reject a load or provide a surcharge invoice. But the market's changed with the number of lithium-ion batteries, the one that have entered the system, and what those batteries and other hazards, propane tanks, etc., are doing to our facilities. E-scrap shredders having multiple thermal events on a regular basis, landfills catching on fire, tipping floors on fire at MRF lines burning down. We've all read the stories. We all talk about it. The number of working groups at the local, state, federal level in the U.S. and Canada that are designed to address hazards in the waste stream has exploded. I'm regularly seeing groups come together and say, "Hey, we've got a problem, and that problem is we've got hazards mixed in with our stuff, and we don't know what to do." Not shocking to anyone on the call, I'm sure. So, true visibility is a lot harder than it sounds, and that's not surprising to anyone on this call, I'm sure. Up until now, as I mentioned, you can have eyes on from staff trying to identify something that's non-conforming, potentially hazardous. You can have a camera that again acts like eyeballs that can sometimes see what could be potentially a non-conforming or a hazard. But beyond that, there hasn't been many advancements. And as you know, material that we're receiving at our facilities across the waste and recycling industry, it's nuanced, it's evolving, it varies by season, particularly in bulk and hazardous waste, as many of you on this call manage bulk and hazardous waste programs. Also with MRFs, see seasonality when spring hits and winter hits. And ultimately, if you can't see it, how do you identify it? So burden depth is one of the largest challenges you see in this market. And think about a MRF line that's got a pre-sort line. If a piece of cardboard is covering up your PET bottle or covering up a battery, how would your staff or how would your cameras see it? And the answer to this point is then it won't. It just won't see it, and you can't take action. So what have we developed and as an option in the market? And you're going to see more companies moving this direction. There are multiple companies that have developed camera systems to identify waste composition and reporting, which is a good, very first step. You'll see companies that react to fires with heat sensing cameras and automated fire hoses in warehouses. Again, a fair step in preventing the facility burn down, but not a fair step in preventing the fire from starting or identifying the hazardous waste composition. So what we've done at Adisia is combine the traditional camera systems, which can identify waste composition and things that we can see with our eyes being bulky items or hazardous items, with X-ray systems and at a variety of sizes depending on application. And the X-rays can see through burden depth. So if it's an item that's buried underneath cardboard, paper, plastic, it does not impact the ability for an X-ray system to identify that item. Full truck scanning to identify composition and hazards within entire shipping containers, much like you see at the port of entry with Homeland Security and Border Control. That same technology can be used with proper software, AI, and machine learning to provide true visibility into composition and really identify hazards before they become hazards in your facilities. Some other things that this can do is integration into ERP systems, invoicing, and moving forward, even the idea of decreasing or at least allowing access to insurance, which is a whole other subject we've all been dealing with in the lack of coverage or the ability to have affordable coverage for our recycling operations. One of the things that's in talking with customers, prospects, and kind of new industries within waste and recycling, it's one thing to identify composition, one thing to identify hazards. It's another to be able to provide data and information in real time, which allows a staff person, a manager, a maintenance manager to react and take action. And you think this is really a differentiation for the industry, is being able to integrate the technology into identification processes, which can vary. So it can be a waste to energy tip floor that the camera system identifies mattress or a large tree stump or propane tank or industrial waste in drums, all things that get delivered when waste energy facilities are not interested in that being delivered, or transition that same conversation to a MRF or to an e-waste facility. And that bulky item or non-conforming waste identified through an app to a user at in a loader to say in bay 6, for example, we think there's a mattress, take action, and then having that operator be able to decide, yes, it's been resolved, no, it's not, or no, it's not a hazard, and allowing the machine learning to learn and update its software virtually automatically, or having a material run through an X-ray system, and the X-ray does a fine job of identifying, hey, this box has a kid's toy in it, the kid's toy has a lithium-ion battery in it. But then as it exits the X-ray, the system literally points a laser at that box so that your operator can stand at their picking station and just remove any items that have a laser shining on that product. This is actually happening. So the systems, although it's fairly new, have been installed at a number of e-scrap operations. Waste Energy, largest waste energy operator in North America, at C&D operators, and at MRFs, using a combination of cameras only or cameras and X-rays, depending on use case within those specific facilities. And what you're seeing on the left side of the screen is just some data that it's kind of an average take on the value that having an automated identification process with actionable data can have on the facility. In fact, just had a testimonial. The video is not ready, so I can't show it to you today, but we can certainly get you a copy if you're interested. The E-Scrap facility that first installed the X-ray has not had a single thermal event in their shredder since installing the unit last October. And this has been an industry, and I know there's a few E-Wave folks on this call that regularly has problems, even after manually sorting material. Regularly has problems with fires and small explosions within their shred systems or other processes. And keep in mind that the systems, because it's AI and machine learning, it doesn't just identify faulty items or batteries, it identifies everything. So if you have other items that you want to report on, other items you want to remove from your systems, it can do that as well. For instance, these scrap shredders operations don't want thick metal in the shredders with counterweights, some motors. The system will identify that and allow your staff to pick that off as well. MERS has certain other contaminants they don't want. Same thing for waste energy and down the list of sites. There's a few slides here where I'll go over just some case studies. Hopefully this generates some questions out of the group. There's only a handful of more slides, but I want to show you how the systems can work in combination or as independent systems and what they really are intended to do, but then talk about what the systems can do, because there's certainly other aspects within waste and recycling where there's value in identifying and reporting on waste composition and hazards. And I'll talk a little bit about that at the end of the presentation, but I'd like you to think about that as well in your operations in how this could benefit kind of nuanced facilities and processes that you have at your individual sites. So FTR Recycling was the first purchaser of the X-ray system. The idea was to remove the manual process of dumping mixed e-waste. Think of things that would be dropped off in a Goodwill or municipal collection. There's a lot of municipal folks on this call, county folks, your HHW sites, your e-scrap collection days, you're throwing kids' toys, toothbrushes, old cell phones, old tablets. You might get water meters from your city programs. These things have embedded batteries at times, and oftentimes they don't. Sometimes they have alkaline, which typically aren't considered hazardous in a system, and sometimes they have NiCad, lead, or lithium, which would be considered hazardous in a processing system. The current process in most e-scrap folks is to manually go through that. We've got 5, 6, 10, 15 staff standing at a table, and you're looking at every single item. If it looks like it has a battery, you're using a screwdriver or a hammer or a chisel or combination to open those items up to determine, one, does it have a battery? Two, what kind of battery is it? Time consuming and prone to human error. The X-ray system changes all of that. And essentially you can see the rotating forks tipping the mixed load of electronics. It's everything I just mentioned, is toys and e-cigarettes and tablets onto a belt. The X-ray identifies, you can see in that photo, the X-ray looks very similar to what you see at a TSA screen. It's the exact same technology. In fact, these X-ray systems were designed for TSA at airports. Operates the same, it's just looking for something different. It's identified a battery as it leaves that system. They'll shine a laser on that item, and the staff member will remove that item from the belt before the rest of the material falls into a tip hopper to be considered shred ready at that point. Production increases, they're saying 400%, it could be more depending on the product. Zero thermal incidences, which is a significant improvement for downtime and staff safety as well. In addition, there's dashboard reporting on actual items removed, item composition, how many printers, how many laptops, how many kids' toys, etc. that the recycler has access to in real time as they're using the system. Another application, as we discussed, is MRFs. You can see a similar X-ray unit built into a pre-sort line, which, if you're familiar with MRFs, is typically the first cause to action location. Material is loaded onto the in-feed belts and it goes to a pre-sort. Pre-sort is typically manned by, we'll say, 4 to 8 staff members, and their job is to remove material they don't want on the line, usually film, plastic, and then faulty items and hazards as well, including batteries, propane tanks, toner cartridges, etc. And this system, again, takes a manual process, which is inherent to human error and missed opportunity from burden depth issues. Like I mentioned, things buried under paper, cardboard, plastic, they just can't be seen by the human eye, and automates that process however you'd like to see it automated. So the laser will shine on whatever we tell it to shine on, and we tell it to shine on whatever you tell us to shine that on. What you see is most of the time the requests are also coming around the more standard hazards, which would be batteries and propane tanks. Again, significant improvement in production, but also a cost savings in less downtime reporting. Another use case currently operational is waste to energy. Again, I know I think half the folks on this call are from Florida. Many of you are either running waste to energy operations or partnering with Covanta or others on your waste to energy operations. I think there's some counties, or at least one county, that's looking at building an additional waste to energy facility. I might be wrong there, but I think I heard that. It's again, the amount of downtime and risk to a facility due to non-conforming material coming in is significant. And up until automating the process, it was simply your loader operator needing to identify what they see as hazards. And the ability to automate that with the camera system has created a significant improvement in production, reduction in downtime, and reduction in damage to their operations. Additionally, they'd ask for support in auto invoicing the non-conforming material. So we're moving forward with that process where a truck backs up, we get a camera scan of the license plates attached to an account, customer account, and then if there's a non-conforming waste, it's faulty. You can see that's a mattress, no matter how dirty and nasty they are, and they're dirty and nasty, as you know. It identifies that as a non-conformance. It'll identify drums, it'll identify red bag waste, medical waste, or containers, and identify the loader operator, then also auto invoice or add to the accounting surcharges that a customer might have as part of that their contract and dropping off material that they shouldn't be dropping off. You can see some of the data, 50% plus increase in efficiency from just using a camera system with some automated actionable texts and app awareness pushes to operators. The last case study is C&D. This is a new product we've installed for some C&D recyclers. This is heavily related to reporting. Again, can identify hazards, can identify non-conformances, which even at C&D sites, as many of you know, do end up on your in your areas. But this is more related to reporting for LEED compliant projects. Many of you deal with this, and you have to do manual identification, literally going out and trying to guesstimate what percent of the load is concrete versus cardboard versus wood and or fabric or other, and then reporting that to the builder so they can qualify for their LEED compliant credits. Doing that with human power is extremely costly and inherently inaccurate because it truly is a guesstimate. It's the only process that exists today that we're familiar with. We're automating that process for C&D operators. And again, from a cost savings, personnel redeployment or personnel reduction, a significant value improvement, but also data that is defensible with video, photos, and something from a reporting standpoint, we feel really improves the process for the companies looking for their lead certification. I'm almost done, then we'll open up questions, which is should have a decent amount of time for that. I just wanted to mention that the ability to train the camera systems and the X-ray systems really has no limit. I'm not a software engineer. I'm just a garbage man. I have been for a couple decades, but the team that program write the software code are all software engineers, and it really is pretty incredible from my perspective to see what they're able to do in training the systems and then having the systems develop on their own. And the ability for this type of X-ray / camera or one of the other systems to provide value transcends just transcends beyond the case study segments that I've discussed. In fact, we're having conversations with HHW operators. That's really what NAMA focuses on. And there are a number of facilities that get paid, particularly north of the U.S. border, based on EPR programs. And in those programs, they need to audit their waste to properly assign costs to manufacturers. Right now, that's done manually. If you can automate that process with a camera system to identify brands of paint and attach that back to actual reporting and photos for the EPR programs, we think that could be a game changer for the industry. Also, identifying needles in boxes and bags through an X-ray system, a smaller X-ray system, more capital effective for an HHW facility, but improving safety for HHW staff is the key that I think products like this can help in the future. We're having a conversation with landfill operators who are dealing with battery fires, dealing with non-conformances, dealing with MRFs that are supposed to be providing sorted only residue to the landfill, but as you know, on average, MRFs are sending 30 to 7% of material to landfills that are actually recoverable material, whether it's organics or plastics or wood or what other diversion programs that the landfills may have. Can we identify that composition in a truck and report that back so there can be action taken as far as education, action taken as far as fines or rejection of loads, and action taken to improve the lifespan of the landfill? The answer is absolutely, we can. And this is the more futuristic thought, but can we do that at the curb with a cart as well? I think the answer is yes. It just has to be engineered and designed so that it's safe for the staff and for any individual that may be around those carts. But being able to prevent batteries and other hazards getting into side and front load trucks is really where I think that this game ends, where we really start to make a significant difference. And that is something that is being discussed or worked on. Medical waste, same thing. There are a number of medical waste processors that are required to shred material because they're sending the shredded medical waste through an ozone treatment or through chemical treatment, or the state requires that it be shredded before landfill. There's only a handful of those that exist, but they still do exist. Their shredders are blowing up all the time from a titanium hip or a scalpel that's inappropriately put into a sharps container or a red bag. There's no way to see that. The material's not open when it's autoclaved, and when it's shredded, they have significant downtime and damage. Running this material through an AI program and X-ray can identify that easily without any issues of burden or having to open up containers. You look at waste audits. Right now, we're doing the landfill waste audits. At least when I did them years ago, I think they're the same. you're spreading material out on the ground and you have people walking around counting and weighing items. That can be done we can automate that process using AI, using cameras attached to loader buckets and cameras attached to drones. That's a product that's being developed. For the e-waste folks on the line, sorting of material in their ITAD operations is critical to the value of those operations. Sorting printed circuit boards is another extremely valuable, the most valuable portion of ITAD and e-waste operations, but they also are inherently difficult to do. Automating that through camera systems to identify like 5, 10, 15, 25 different grades of boards. Now you don't have to train staff, you just put the material on a conveyor and the system sorts the material for you. Same thing with grading of reusable electronics. Now ABCD, if you're refurbishing phones and tablets and laptops, is there a way to automate that process using cameras and X-ray? We think that there are. And then other. And this is where I'd like to open it up for questions. As you think about your operations, what else could AI, machine learning, cameras, and X-rays do to provide visibility into your material and to help safety and production and efficiencies at your facilities? Is really the ultimate question. And I think that there'll be more and more companies and more AI technology that can help support those requests. With that, I'm done talking. Got about 20 minutes, I think, for questions. And this is my first time doing this in a couple of years. So how does this work?
There are any questions, you can go into the Q&A chat. Not seeing any so far.
Excellent. You might give everyone half hour of the day back. Please, if there's any questions or follow-up, you know how to get a hold of me. We'll give it to you a couple minutes to see if anyone has any thoughts or questions they'd like to answer. Just contact. Okay, here's the first comment from an anonymous attendee. Chat is disabled, so people aren't jumping in. I don't know how to enable it.
The chat should be open now.
Okay, everyone hear that? Chat should be open now. If you've got any questions, we'll give another minute. Okay, well, thank you again, everyone. Oh, hold on a second. Thank you, everyone, for attending. Hopefully this was insightful, and appreciate your time, and we'll give you 20 minutes of the day back. Thank you very much.